Alright, so in this part of the tutorial we're gonna have a look at some basic control structures called composite nodes. So as I introduced earlier, in the behavior tree there's two categories, let's say, of nodes. There's the leaf nodes, or the atomic or the unit nodes if you want, which are the ones that we've seen already, which are just nodes that accomplish a single action. So like we've seen already, there's like if I bring them up, there's the you can set Blackboard variables, you can have a constant, you can have delay. So these are all, or text, these are all unit or action nodes. But the power of the real power, true power of the behavior tree lies in the control structures that it provides to organize these actions, to choose how these actions are going to be performed, in which order, and under which condition, etc., etc. So this leads us to this other category of node, the second category of node, called composite nodes. And composite nodes are simply nodes that contain other nodes. They have children nodes, and each type of composite node will prescribe a certain way of running through their children. Okay, so we're going to begin by the most simple of these composite nodes, which is called the sequence. So I'm going to add sequence. Okay, so I created the sequence node, and then Control Tab, I'm going to create a children for this node. And I'm going to create, let's say, text1, and then I'll create a if I create a delay, and I'll create another text. Okay, let's see what happens if I run this. So okay, so before I start, so the sequence node, what it does is it will run through each of its children in order. It runs through its children until one of them fails. If one of them fails, the sequence immediately fails. Or if it is able to run through all its children and they all succeed, then it will also return success. So let's see what happens. Went really fast, but basically the three nodes were run in order. They all succeeded, so the sequence succeeds. And since this is the only node, it ends there. There's a little symbol here, by the way, which allows you to expand the node. Really useful for especially when you have really large compositions. Okay. So in order just to sort of simulate what happens if one of the nodes fails, I'm going to add a constant here, a constant node, which is going to always return failure. Okay, I'm just going to add it, and I'll add it, let's say, here. Okay, let's see what happens. All right. So what happened is that the sequence tried the first children, it succeeded. Tried the second one, it ran for a while because it's a delay, then it succeeded. Went to the third children. Now the third children, the third child failed. So because it failed, the sequence immediately failed, and it did not accomplish the last element. Okay. So it's like, if I tell you, if I give you a sequence of action to reach a certain point, I don't know, I tell a robot, okay, to go, if you want to go in the corner over there, what you do is like, you run through, you run in that direction for some time, then you run in that direction from some other time, and then you do this. Well, if at any point something goes wrong, the robot is not really able to tell what to do, so it's just going to exit. Okay, that's the idea behind the sequence. Now, completely opposite to the sequence is what we call the selector, and I'm just going to introduce it very briefly. So I'm just going to replace it by using Control E for editing. I'm going to replace this sequence by a selector. Okay, and let's see what happens. So the selector does exactly the opposite. Like I said, the sequence runs through all of its children until one of them fails, while the selector runs through all its children until one of them succeeds. So as soon as one of them succeeds, it won't try the other one. It's like it's also often called a priority node. It will prioritize the first action. If it doesn't work, then it will go to the second one. So what I'm going to do is by selecting this node and using Control and the arrow keys, I'm just going to move this constant node to the top just to show you what happens. So here, if I run this again, you'll see that in this case, it tried to accomplish the first node, but it failed. So because of this, it went to the second one, and the second one succeeded, so it stopped right there. Okay? That's the selector node.